Welcome to Altair Engineering Training and Support. In this video, I am going to show you how to perform analysis on a 2D meshed roll cage structure where you have created the mesh models, the 2D mesh model. So how to perform the different types of analysis in that. So in this video, we are going to discuss how to perform front impact analysis, then side impact analysis, bump analysis, rollover analysis, torsional analysis, and modal analysis. These 6 analyses we are going to perform in the same file, or you can divide these files in the different folders and then run the analysis. So I will show you both, making the model in solving in one file, viewing the results, solving it one time and viewing the 6 different results, or you can again divide it into 6 different files also. So we'll start our session with opening of the hypermesh. So we'll open the hypermesh. Make sure you select the user profile as Radios bulk data, because we are going to create perform static analysis. So make sure you select Radios bulk data format. Click OK to load this bulk data format. At the top, after clicking on the Radios bulk data, on the top, make sure you have select the appropriate user profile has been loaded. As you can see here, the Radios bulk data format is loaded. Then click on open folder and browse the file where you have saved the FEM file. This is the meshed file. So this is my meshed file which I have browsed. You can see the welding, and we have divided these weld joints in a separate component. We haven't provided any material properties to it, but just we have divided it into different components so that we can later on we can define them. So I will first start with how to define the material properties, and then we'll follow the same process. We'll follow the same process as MPCLL. So to define MPCLL, my first is to create material. So here I will name it as, say, steel. I am using the base material as steel. Define an appropriate color. Select the type as isotropic and card image as matte 1. Click on create edit to enter to create edit panel. Then enter the values of E, new and row. Click return. Then create the material of weld, name it as appropriate material name. Select the type as isotropic, card image as matte 1 and click on create edit. Enter the values of weld material. This time I am changing the weld material properties from steel, as we are going to enter the values of 2.5 e to the power 6, and new is I am going to change as 2.8. Density will be somewhere will be same but a little less. So I am changing these values. You have to enter the accurate values of the material which you are using, the weld material which you are using. You have to use that accurate values of E, new and row. Then click return. So on the model browser you can see my material and weld. The material as steel and weld has been defined. So now I will assign 2 different properties. One is roll cage pipes. So in between the pipes I will name it as roll cage pipes. Define a proper color. This time select the type as 2D. Select the card image as P shell, material as steel. Click on create edit and enter the value of T as thickness 3. T stands for the thickness. Enter this value as 3. Similarly, define the property for weld. So roll cage weld. Give them a different color so that we can easily see on the element color mode here. Select the type same as 2D, card image, P shell. This time change the material to weld. Click on create edit, again enter the value as 3. Sometimes people used to change the thickness of the weld material also. So during the weld, the material thickness also changes, so we can use 3.2 also, a little bit change in the thickness. Then click return to exit the property collector panel. So on the model browser you can see my two properties has got created. Now I will update this component accordingly. So go to component, select the radio button as update, click on the component first, select the roll cage, mid surface, the pipe one, toggle down to property to no property to property, select the roll cage pipes, click update, then select the weld, again toggle it down and select the property of roll cage weld, click update. So in this way you have updated these properties. So we'll just cross check it. By property, change the color, so the color properties of pipe is same and weld is perfect. Then by material, the element should get a different color. Material as steel here and weld elements as here. So all the properties and components are now been updated. So now my next step is to define the load collectors. So I will click on load collector icon, enter the name as front impact force. As I am solving this all the 6 cases in one single file, so I will name it properly, so to lower down my confusion. Click create and again click on front impact, name it as front impact SPC. SPC stands for single point constraint. You can also name it as constraint and click create. Keep all the other parameters as it is. So you can see you have defined front impact force and front impact SPC. Then we will apply these forces and constraint on our model. So select analysis constraint, as my constraint is the current load collector, so select constraint. For the frontal impact, we will follow the same process, that we are going to constrain this front suspension pickup points on the degree of freedom 2, that we don't want to move these on the upward direction. As per your model, you can constrain these. So for this particular structure, I am going to constrain these pickup points. So I will off this and constrain all the suspension pickup points, the front one. So 1, 2, 3, these two and these two, and click create. So here you can see the constraint has been applied on this model. If I on this, so here are the frontal constraints. Now we will constrain the rear end. So again I will off this. At the rear end we are going to constrain all the 3 degrees of freedom. So we will constrain these. Again I will off the meshing and also constrain the top one. So off this meshing, these we are going to constrain. Click create to apply the constraint. So in this way I have constrained this model at degree of freedom 1, 2, 3 at the rear portion and degree of freedom 2 on the frontal side. Now I will apply the force. So I will make this as current and apply the force at this beam section, the front beam section. We can use the joints also to apply the forces, or only apply the forces at pipe. So I will use different models to apply the forces at different location. So for frontal impact I will apply only the force at the joints location. So to apply the forces at only the joint location, you can either you can apply the forces at the half side, that is the frontal side, or you can apply through the complete side. So I will apply for the complete portion. So I will make it in this way. Click return and then press shift F2 to add the nodes of this roll cage structure. Click add. So these nodes are now added on this and off these. Then I will add the nodes on this side. So I am going to apply a force on complete front side. Shift plus left click, drag the window. So in this way you can see I have selected all the nodes, click add. So I have added all the nodes, as you can see on the front side where I am going to apply the force. Then click return. Of these two meshing, go to analysis, forces, select all the nodes which you have created. So it will show you that 3586 nodes has added. So it contains 3586 nodes, as you can see. Once you select, don't move the model, so it will be highlighted only, it will be highlighted. So 3586. So let's suppose if I apply a force of 1000 Newton, you can apply either 3G, 2G, 4G, as per your model or as per your calculation you can apply different forces. So let's suppose for this model I am applying a force of 1000 Newton or say 3000 Newton, that is 1G. I am going to apply a force of 1G, so I will show you the calculation for 1G. So if we consider weight of the vehicle to be 400 kg, then G will be 400 multiplied by 10, which will be 4000 Newton. So 1G is 4000 Newton. So if you want to apply 2G, that will be 2 multiplied by 4000, that is 8000 Newton. If you want to apply 3G, similar the calculation will be. If you want to apply 3G, so 3 multiplied by 4000, that is 12,000 Newton. Similarly for 4G, 5G, 6G, you have to decide what amount of force you are going to apply on your model. So I am going to apply a force of 4000 in frontal impact for this particular model. So we divide this 4000, you have to divide total number of force, total force you want to apply on this side divided by total number of nodes. So 3586, which is where you can see here, that is 3586. So this is the force. Copy this and paste it here. So this is the force on each node I am going to apply. So this complete frontal end will have a 1G Newton of force, that is 4000 Newton of force. Now we will select the direction of forces. So for frontal impact, my direction of force will be in Z-axis. So I will select from the drop box Z-axis, select the global system and click on create. So once you click create, you can see forces has got generated. Each one is having a value, as you can see here, 1.12. So the total will be 4000. Similarly, if you are applying 2G, that means 8000 Newton of force. So divide 8000 by total number of nodes selected there and apply the force on this. So once my node is clear, so I will clear these nodes. You can off this from here. So I have applied the forces and constraint on my model for the front impact analysis. So I will create a load collector for this. So go to analysis, load step, front impact, select the type of analysis as linear static, select SPC as front impact SPC, for load as front impact force and click create. So in this way you can see on the model browser my front impact load gauge is set. So either I can solve this file individually for all the different load cases, or I can apply the forces and constraint on this same model and define different load step and run the file once to find all the results of all the types of analysis. So I will show you how to do that. Now again I will click return and again go to load collector panel. Now I will create side impact force, give him a red color, and side impact SPC, giving the blue color. So I have created these two. So my constraint is highlighted, so I will create constraint first. So go to analysis, constraint. For side impact members, I am taking only the lower suspension pickup points to constrain the model and apply the forces from on this bar. So I will again off this, select the nodes, here you have to make sure you have selected these also. So deselect, right shift plus right click and deselect these. If you on the meshing, you can see I have selected only the lower suspension pickup points. We'll constrain for all the 3 degrees of freedom and click create. So they are got constrained. So as you can see here. Now I will right click on the model browser and make the side impact force as current component and go to analysis, forces. This time I am going to apply the force from this end to this end. That is again I am going to apply a UDL. So I will off this weld. Again go to shift F2 from my keyboard. Add the nodes on complete side member. We'll also take the weld. So I will pick the weld also. So again I will off this welds and select this. So I have selected this complete segment on this again and click create. So from this end to this end I am going to apply a force. Again the force will be same, that is 4000 Newton, that is 1G. You have to apply as per your model structure, as per your calculations. So I will click return. Of this meshing and weld meshing, of these all the two meshing. Go to analysis, forces, select the nodes, that is 7 to 72 nodes are there. So I will go to 4000 force divided by total number of nodes. So force on each node will be 0.55. I will apply this. The direction of the force will be in z-axis, so I will pick as z-axis and click create. So my forces are now get created. As the magnitude is very less, so I can increase the magnitude. So here you can see the forces has got created. If I on the points here, you can see at each node the value of force is 0.55. So total on all the calculating all the nodes, the total force is coming as 4000 Newton. So in the same way you have to apply for the your segment. Click shift F2 and clear the nodes once it is get clear. Once you have applied these forces, then go to analysis, again load step, create side impact as the load step. Select SPC as side impact SPC, load as side impact force and click create. Keep all the other parameters as it is. Of these two, now this next one is bump analysis. So again I will go to hypermesh, go to load collector, bump force, make it in a red and say create, and bump SPC. Give him a blue color and say create. So as my SPC is current, so I will first create the constraint. For bump analysis, I am going to constrain the rear end and apply the force in upward direction at the front end. So I will again off this. So you will find these all these nodes. only these weld joints. So I am applying the forces or constraint only in the weld location. So here and at the top. Say create. If I on this model, you can see I have applied the force at the front end. And now we will apply the forces on all the 8 suspension front points. So first I need to calculate, go to analysis, forces, make bump forces as the current component, so the forces will move towards that. Then on, select the nodes or go to shift F2, add these nodes, select all the nodes. So these are the areas where I am going to apply the force. Click add. Always make sure that you have selected the correct suspension pickup point. So this is the correct one. Of these two, select all the nodes. So the total nodes coming as 3432. For front impact also, for bump analysis also I am going to apply the force of 4000 and we'll check what will the analysis. So 4000 divided by 3432. Copy this and paste it here. For bump analysis, my direction of force will be in y-axis and we'll click create. Again shift F2 and clear all the nodes. So here you can see the forces has got created in all the forces has got created in y-axis. So the total amount of force on the all 8 suspension pickup points is 4000. So total force divided by total number of nodes you can apply directly on your model. Then again we'll go to analysis, load step. This time I will put it as bump analysis, SPC as bump SPC, load as bump force, click create. So my third load step is defined. Again I will opt these two. Now my next is to define rollover analysis. So I will define that rollover case. So for rollover analysis I am going to apply the force at this angular position. So for that I will first create a local coordinate system to apply the forces at angular direction. The process is same exactly as we have created in the 1D structure. So we will create the same way. First we have to find out the center node, or we can create anywhere in between this. So if this is a perfect circular, so we will create a center node here, that is by taking any 3 arbitrary nodes. Press F4 from your keyboard, go to 3 nodes, click circle center. So this is the center of the circle. So we have to define X and Y points. So again F2, this will be shift F2 to add the nodes in X and Y plane. Or to get a perfect node, go to shift F4, select this node, enter the magnitude as 10, select axis as X, click on the node again and say duplicate, translate it, again select this node, click duplicate, this time select the axis as Y, select this single node, axis as Y and translate it. So I have defined a XY plane here. So go to 1D, systems, select the node where you want to create a system. The origin will also be the same. Select X axis as the global X axis and XY plane, select the global and say create. The system may be small, so you can magnify it by changing the size. So this is my local coordinate system. Now I will rotate this system to 45 degree to apply the angular forces. So go to rotate this system, go to tools, rotate. From the drop box, select systems, pick the system. I want to rotate in x-axis with an angle of 45 degree. The base point will be the same as the origin and select rotate positive. Again you can on this. So this is the system where we can apply a 45 degree angular force with reference to this. So again we will create two different load collectors. First is rollover force, create, and rollover SPC, create. Again go to analysis, constraint. As my constraint is the current, make sure the current, the bold one is the current. We'll apply the forces for all the 3 degrees of freedom at front and rear end, both the ends for rollover for this structure. So I'm going to apply these constraints on these all these locations, as you can see. And we'll apply the force at this top location for the rollover simulation. So I will off this again. Make the force as the current one. Click return to exit the constraint panel. Analysis, forces. Shift F2 plus delete these nodes which I have created and add the nodes, add the new nodes here. Then move this, go to analysis, forces, select these nodes. So there are total 794 nodes. For rollover also I am going to apply 4000 Newton of force. 4000 divided by 794. So the node force per node is coming as 5. So I will apply that. This time change to local coordinate system, pick this, select y-axis, because if I on this, you can see the direction of force which tends to roll over this will be y-axis force, this direction force, and say create. So the forces will be in y-axis, as you can see. Click return, go to analysis, load step, enter the load step for rollover analysis, select SPC as rollover SPC, load as rollover force, and say create. So my fourth load case is created now. Again press Shift F2 and clear all the nodes which we have created. Now the next is to define torsional analysis. So now I will create a different load case for torsional analysis. So for torsional analysis also I will follow the same. Go to load collector, torsional force, define a color, create, and torsional SPC, define a color, and create. So in this way you have created two more load collectors. Go to analysis, constraint. Again for the torsional we are going to constrain the rear end. So I will off this select these nodes, and create a constraint here. Check it whether the constraints are properly at the proper location or not. And for torsional analysis, we are going to apply a y direction positive and negative force at one end and the opposite. So similarly, I will opt this again. Go and create the nodes, shift F2, add the nodes and this end and the other end. On this and just cross check it whether the node selection is proper or not. Yes, the node selection is proper. So I will off these both. So at the one end I am going to apply 4000 downward force or negative direction up, and the other way I am going to apply 4000 Newton of force in the positive y direction. So make this as torsional force, make current. Go to analysis, forces, change this to global coordinate system. Select these nodes. So total number of nodes is 1758. Go to calculator. So 4000 divided by 1758 gives 2.27. So here in this side I am going to apply a positive force. Again select these nodes. The total number of nodes is 1760. Go to calculator and 4000 divided by 1760 comes as 2.2, but this is the negative axis, so I will put it negative value and say create. Again press shift F2 and clear all the nodes once my force is getting applied. So here you can see, I'll go to mask, this load, mask and reverse. So if I go to forces and just magnify these values, so you can see at the one end I have applied all the forces in upward direction, another way I have applied the forces in downward direction. If I on these forces, so you can see here in this way we have applied it. Now we will create a load step for this. So torsional analysis, check SPC as torsional SPC, load as torsional force, make the type as linear static, click create. So the fifth load case is ready. Now I will again opt these two. Now my last load case is to the modal analysis. So I will again go to load collector, create modal SPC, and to define a frequency range I will put it a value of EIGRL from no card image, enter to card image, select the card image as EIGRL, click on create edit, enter the values of V1, V2 and ND, enter the value as V1. For this particular model I am using the frequency range from 1 to, let's suppose, 200, and I want to see the first 10 modes and click return. Again click on return, and now I will apply the constraints on all the suspension pickup points, 8 at the front, 8 at the rear. So go to analysis, constraint, make model SPC as current of these so that it will be easy to pick. Select these nodes at the front, click create, and select the suspension pickup points of the rear. If I on this, just cross check it whether all the suspension pickup points are correct or not. So yeah, it is correct. So go to analysis, load step, For modal analysis, select the type as normal modes. Check the SPC for modal SPC and method structure as EIGRL. Enter the value as modal analysis and say create. So one more load step, the sixth one, modal analysis, has got created. Now I will save this file, name it as complete analysis and click save. Go to analysis, radius of this also. Go to analysis radius, select export option to all, run option to analysis, memory option to default. Save the FEM file in this location and click on radius. So once you click on radius, it will start processing it. As there are so many load cases, so it will take a little time, but it will get solved very fast as compared to the 6 different load case files which you will create in a 6 different way. So you can create either of the way, create 6 different files for different types of analysis, or create a one file in which you can perform all the 6 analysis. You can view the results separately also, so that I will show you. Or I will show you how to divide this same file into 6 different analysis. So click on save as, enter as front impact, click save. From this end to this end, delete these load collectors and delete this load case also. Click on save as and save this file for front impact. So this is the file for front impact. Click on new, open folder. Again go to complete analysis, open that HM file. Then delete these front impact forces. Delete from here to here the side impact forces. Delete the front impact load collector. Delete these load collectors and save this file as side impact analysis. Now again click on open, complete analysis, open the file. Now create a bump analysis file. So if you want to create 6 different files, so you can modify it simply and run it in a separate way. So from here to here, delete, yes. Click save as. Enter as bump analysis and click save. So this is the file for bump impact, bump analysis. Again click new, complete analysis. From front to bump, delete these. For torsional to EIGRL, delete these. Open the load collector, front to bump, delete. For torsional to modal, delete. So once you create one single file, you can modify it with easily. So this is the case of rollover. So if you want to run it separately, you can run that separately also. If you run it in the same file, you can run it in the same file. The results will be same. There is no change in the results. So from front impact to rollover, delete this. For the load step, delete. Modal analysis, delete. For modal analysis, delete. Always save as, don't save this file. Always go to save as option, create a new folder as TORSIO, torsional analysis. Save this file. Similarly, again open a new, go to complete one, open this, go to load step from here to here, delete all the load collectors and delete all the load step, keeping the one only. Go to save as, create a folder for modal analysis, save the file. So in this way you can see I have created 6 different files, and I can run them and view the results. So go to analysis, radios. I will run them also one by one. That is the 6 different files, I will run them one by one. So this is for radios, modal analysis. Go to analysis, radios page. We'll solve for the modal analysis. As this run is in progress, so it will take some time to solve this, as the earlier run is still in progress, because it is solving the 6 different load cases in one single file, so it will take some time to solve. So as you can see here, it started a different one, a new one. As you can see here, I am performing 2 runs here. One is for the complete file and one is only for the modal analysis. So now as you can see, one run is completed here. So I will click on results. So this is the file where I have done the 6 analysis in one single file. So this run is completed now. So I will click on results to open the results in Hyperview. And close this once my solver is done. So I will close this file. This is the license message that the license will expire in these many days. So here is my resultant roll case structure. As you can see, this is my resultant roll case structure. So I'll go to contour, say displacement and apply. So my displacement for front impact is coming as, I'll go to measures, static min max. So maximum displacement is coming as 1.5 mm. The forces are very less, that's why the displacement is so that much. If I change the load case from here, on this end you can change the load case type. So this is due to the side impact displacement value. This is due to the bump analysis, the value of displacement. This is due to the rollover value of displacement. Torsional analysis, and for if you change the modal, the mode shape you have to find, so that we'll see later on. Again, for front impact, we'll go to result, click on contour, select the result type, element stresses, select one MISES, simple, and apply. So these are the stresses which are coming. For the front impact, this is due to the side impact. This one is due to the bump analysis. This one is due to the rollover analysis, As my roll cage structure is, you can see this, it's very weak. There are no members, so that's why the force stresses are coming way high, even though the forces are very less. So it may vary on your model, so you don't worry about the stress values. I have explained the process how to apply that in this video. And then after rollover, this is due to the torsional analysis. So in this way you can just scroll down. Now we'll see the analysis of the modules. So select again contour, Eigen modes. Select, this is the first frequency mode, second, third, fourth, fifth, sixth, seventh, eighth and ninth. So these are the 10 different mode shapes. Now we will see for the animation. Go to again contour, elemental stress and apply. As the deformation is very less, so we will just magnify the deformation so it will be easily visible. So this is the deformation due to front impact analysis. If I change it, this is due to the side impact. The deformation or the displacement value is very high, so we will change it to 10, so it is more logical, as you can see. Then on the third one, it is due to the bump analysis. For this also you can change the deformation. For fourth, this is the rollover, the displacement. If displacement value is very less, you can just magnify it, or you can just magnify a little more. So this is due to the rollover. Then this one is due to the torsional analysis. And these are the due to modal shapes, different Eigen modes you can see. This is the first one, due to second, third, fourth, fifth, sixth, seventh, eighth, ninth and 10th. So in this way you can run the same file and capture the different results. I will show you how to capture them. So if you want to capture the displacement value due to torsional, or say let's say for front, if you want to capture the value of displacement due to front, select the front impact analysis, the position where you want to capture the image, that if this one is you feel the best one. If you want to show this, show, otherwise if you want to hide this, you can hide this also. Also you can hide from here the system values. Go to capture the dynamic rectangle and create a rectangle from here. Save this file in front impact displacement, or you can only pick the graphic area, that is front impact displacement 1. Also you can save the animation plot. For that you can have to view the more animation, more time. For the more time you can just click on it and increase the number of frames, or to view the results more accurately you can just increase the deformation value also. So at the end, if you want to check what is the deformation, so okay, this is fine. Capture that also, front impact displacement animation. So animation plot will take some time, so till that time we will see the values of or the images of displacement. As you can see here, this is the displacement plot, or the more precise is this one. Also if you don't want this messages to be taken into image, If you open the hyperview, once this process is done, you can also off these and only plot the graph with this. So this is also possible. I will show you the process. Once the video is converted, it will show you the process. So from title, either here from node you can off this. So it will be get offed and you can put it like this. So this is the graphic area. I will save this as front impact displacement file 2. So here you can see the second. From this, if you want to cut it down to copy it in Windows 7, you can simply use this end to this end and copy it. So this will be, you can use this anywhere. So this is the maximum displacement. If you want to show the maximum displacement in image, just open the major panel, open static maximum minimum results and open the panel here, and again you can capture the same results same way. Just click on this and capture the results. Front impact displacement 3. From here you can, this is the maximum value at this node, out displacement. So in the same way, for anyone, for the front impact displacement, for front impact stresses also, the process is same. You have to just click on this for images, and if you want to view the video, you can also view that video also. So this is front impact AVI file. So this is the animation plot. Again you can off the nodes to off this. So here it shows the deformation. I've increased the number of frames to very high. You can decrease it a little bit low so that it will be more faster. So in this way you can capture the images and result file of different load cases. So it's your choice if you want to run it in a single file or run a different files. So the results will be same, there will be no change in the results. So you can either have 6 different H3D files, that is the result files, or have one H3D files in which all the results are there, and you can capture the images also. So in this way I have ended this video. Thank you very much.